There are a few things that developers unanimously agree on, but proper source control is one of them. Generally speaking, there are quite a few things that can get you fired in your job. Frequently being late, missing deadlines, acting like a jerk, things like that. For most of these things, you might find forgiveness from your boss and your peers, once, perhaps twice if you're good. But losing the source for your work, or worse yet, your project, will get you fired almost every single time. Or worse, it can even crater your company, or it can get you into some legal trouble. Now, if you're not using source control, consider this the last day of that practice, if only for your own sake. As a reminder, this episode is based on Chapter 3 of Coder to Developer from Mike Gunderloy, with some improvements based on what we know today about source control choices. If you'd like to know more, please consider purchasing this book at Amazon.com. So in this episode, we're going to cover three main topics that revolve around the use of source control. Now, I'm not going to cover each system and how it can be used, but there's more videos here at Tekpub if you want to watch them. Instead, I want to focus on you as a coder and your use of source control. And the first thing I'll cover is what Mike referred to as the path to source control enlightenment, the stages you're going to go through as you start working with source control systems. Next thing I'll talk about is the choices you have in source control systems. And finally, I'll go into everyday use, tips to make working with source control systems easier on you and the rest of your team. Before we get started, let's talk a bit about why you need to be using source control. For many of you out there watching this, the use of a source control system might be completely obvious. The ability to track and version your code over the life of your project is enough motivation in and of itself. However, many new developers prefer to take more of a cowboy approach, copying files to Dropbox or a network share, or maybe just winging it in the name of time. It's just one of those things that's not really a good idea, and in most cases it takes some type of disaster to really push home the idea that a good developer simply must version their work in some type of source control system. Now, it's much more than a code vault, if you will, that tracks the versions of your files. Properly maintained and executed source control system can do a lot for you, your team, your project, and your client, offering a map, if you will, of what happened when. Timely commits with good labeling and tagging, effective use of branching, proficiency in each of these things that we're about to talk about can create a detailed chronology of where your project has been and, potentially, where it is headed. Ultimately, it's about this guy, as always, your client, and answering his questions, especially when something bad happens. You need to be able to go back in time and kind of rewind things occasionally. Take a look at who committed what, when, and why. Effective use of source control protects his investment that he's paying you to create for him. And yes, he cares about you as a developer, but what he really wants to have is a working application that doesn't vanish when a Coke is spilled on the hard drive. A good source management is something you don't want to learn the hard way. At some point in your career, either by force or by shame, you begin to realize that you need to keep your code in a source control system. And perhaps you're lucky and your job is forcing you to use a system, or possibly you're awesome and you know that you need to protect your work. Or maybe it's worse. Maybe you lost a week's worth of work when your external backup drive failed. Perhaps you wanted to revert your work to a change you made last month and you had to rewrite everything because you forgot how you wrote it. Rookie mistakes, all of them, and they can cost you your job. But you're here now, awakened, hooray. You see that protecting your client's investment is incredibly important, not just for them, but for you and your career. So as a newly awakened person to source control, you've read some manuals and you know the basics. You can check out files, you can work on them, comment your check-ins, and you can see how your work progresses over time, and you're able to review the changes you've made in the past. A roadmap of your development process is becoming clear and your code is backed up remotely. You're doing a good job. Commands like checkout, add, clone, and push are becoming familiar. You're beginning to get it. You're beginning to understand, and soon you wonder, what in the world were you thinking? The next stage is the hard hat stage, or what Mike used to call the journeyman stage. You work with source control on a daily basis and you can't function without it, mentally and literally. You're familiar with the tool set, and you've started to use the command line because, well, it's faster. You've even wired in some of these commands into your IDE. You've begun to see how you can flex your source control system to make your work easier, spiking new efforts in different branches and shelving your changes instead of checking them in to keep your trunk clean. You also understand why people use branches, tags, and trunk as the directories in the root of the source control system. And you've also created your first labeled commit. The final stage is mastery, complete understanding of the power of the source control system, the power to save your butt when things go wrong and enforce your development process through your repository. You deftly branch the source for yourself and your team to keep people from stepping on each other's toes. You effectively label your commits for easy reference from your team and from stakeholders. You're the person who people call to set up the repositories in the beginning, wrap it up with rules and security, and who they call to untangle any merges that might come up. And you're also the person who scolds the new developers that don't comment their work properly or when they check in bugs. You don't really care for the GUI tools, preferring the speed of the command line, understanding that you'll be working from many different machines over your career, and that integrating source control into the shell or IDE only slows you down. Working through a GUI is just fine for a lot of folks. If you really want to know a tool, the command line is usually something you cannot replace. Overall, slow and source control don't mix. This is something that you like to argue with people in the lunchroom. And finally, you've become a source control ninja. You are a very, very valuable person to your organization. So another way to look at this is that source control is your best friend as a developer. This is the one thing you must understand deeply. Understanding your source control system transcends languages, frameworks, and platforms, and your mastery of it defines you as a developer and your commitment to your project and to your peers. Most of the time, the selection of a source control system will be made for you by your company or your boss. However, many people, like myself, have found themselves falling into a technical role quite by accident. Or maybe you're on a one-man team, and you get to make the choice for yourself. Or maybe you've been given the task by your company, just choose one for you and your team, if you're transitioning off of an old one, for instance. In this section, I'll go over each of your choices. And once again, I'm not going to go into the features. I'm just going to go into points of consideration for you. So the source control landscape can be divided into two categories, not free and free. It used to be said that you get what you pay for with these systems, but that's changing rapidly as time goes on, and the free, also known as the open source tools out there, start to mature. Many companies will opt to pay rather large sums of money for a good source control system, and not only versions the code, but integrates with the project management tracking systems and policy enforcement. Now, if you work in a Microsoft shop, this usually means working with something like Visual Studio Team System, which sits on top of Team Foundation Server, a fairly massive, all-encompassing system that allows managers to integrate bug tracking, code analysis, unit testing, continuous integration, and a bunch of other buzzwords. Another choice is Perforce, which works a lot like Team System, but it embraces the Agile XP way of doing things, and it leans on speed as a bit of a marketing pitch. It says it's a lot faster than Team System and other systems. I've never used it personally, but I've heard nothing but good things about it. Finally, there's SourceGear, which runs on top of SQL Server. It's a very simple system to use, and a simple system to set up and deploy. It's been around for a really long time, and a lot of developers swear by it. I've used it on a number of projects, and I found it to work just fine. So these systems cost money because they offer you extras that allow managers to exercise more control over the team, and they also integrate fairly seamlessly with the IDE, and that sort of leads managers to think, well, if it's integrated with the IDE, that means my developers will use it. Now, the main question here is, are these tools worth the extra cost? Is it worth the extra cost to have that control and to have that integration with the IDE? This is a question only you can answer for yourself and for your team. Now, it's also worth noting that in addition to paying for the licensing and paying for the extra features, you probably are also going to have to pay for an additional server. Team Foundation Server, for instance, is quite a big program. It requires a lot of licensing and supporting programs to go into it. And that usually means you're going to have an IT person to maintain it and them, as well as backups and other things. So this is for large companies. And so sometimes if you're a small shop, these larger solutions might not make too much sense. But speaking realistically, you're going to typically find yourself working on these systems because someone else made the choice, your boss or your client. So it's worth noting at this point that maybe the control that's in there, maybe the a little extra time it takes to commit check files in, check files out might be a bit of a pain in the butt. But it does not mean you should avoid learning them. In fact, you should make the extra time and effort to learn them because, as I mentioned before, your understanding of the source control system and how to work with it is only going to make your job easier. That's something that is not going to change over your time at your company. In the free category is an emerging set of tools that many top organizations prefer to use. You're probably familiar with Subversion if you've taken any college classes, or if you're a recent graduate, then you've no doubt had a bearded hippie teacher show you CVS. Or maybe you got lucky and that bearded hippie teacher is quite current in technology and decided to show you Git as well, and if that's the case, consider yourself lucky. These are the upstart source control systems that have burst onto the scene in recent years, making a pretty big splash in the tech industry, and we're going to talk about each one of these right now. Subversion is by far the most popular free source management system, aside from just typical file copy to a network share. It's an offshoot of CVS, which is one of the very first open source control systems. Now, Subversion has a lot of great tooling support, so developers, especially Visual Studio, Microsoft developers, find that to be very compelling. Typically, one would use the Tortoise SVN shell integration tool, which I'll show you pictures of in just a minute. In fact, I've already shown you a few. And that makes working with Subversion from Windows a breeze. So the main points about Subversion are that it is centralized. It means that there is a server running software somewhere that listens for you to push files to it. It's quite a secure setup, and it makes integrating with your other team members pretty simple. There's a lot of free tools out there that allow you to set up a Subversion server really quickly. Now, Tortoise is the client. The server software is something that's a little bit different. My personal favorite is Visual SVN, which is a free tool. You can download it, set up Visual SVN server. It's going to install all the things you need to expose Subversion over the web. Speaking of, Subversion is internet friendly, meaning that it works directly with HTTP over whatever port you choose. This is something you can easily set up with Visual SVN. Finally, Subversion is IDE independent, meaning you don't need to have Visual Studio open in order to work with it. It works right through Windows Shell. Next up is one of my favorites, which is Git, created by Linus Torvalds of Linux fame. Many people wonder why Git is named the way it is, and the answer from Linus is that he likes to name things after himself, which is a bit of a joke because he didn't name Linux, somebody else did. Anyway, he decided to call Git Git because, well, he said it's what people like to call me, which is kind of funny. Git is a distributed system, and this means that you don't need to commit to a remote repository over the wire. It's local to your drive. In fact, it's local in your project. It sits right in the root. You do, however, push your local repository to a remote repository when you want to share or have it backed up remotely. This is a merging scenario. In other words, you don't commit remotely, you commit locally and push remotely. This type of architecture makes Git extraordinarily fast, which many developers very much enjoy. When it comes to source control and speed, developers that work with a slower system tend to typically say do not want. They don't want to work with those systems, and if they don't want to work with them, that means their commits are probably going to be less frequent, which means more trouble for you and your source control as a whole. So the speed is a big, big bonus for Git. Next, GitHub is a pretty cool online solution for sharing repositories with others. You can have a public or a private repository, and the tools on GitHub are excellent for collaboration. And many people choose to work with Git simply to work with GitHub. Finally, tooling is an issue for a lot of folks. Git is installed by one of two means, using msysgit, which is by far the most dominant way of doing it on a Windows machine, or by using a emulator called Cygwin. Now, if you install Cygwin, it tends to be a long, tedious process. Many people don't like to have Cygwin on their machines if they're a Windows person. I can tell you from experience that using msysgit is rather painless. But I will tell you that the GUI is pretty useless. The GUI that you get with Git. Learning the command line is generally the way to go, and if you're a visual developer using Visual Studio, whatever, typically I've found people have a bit of a problem with that, but I can tell you from experience that working with a command line tool is rather painless. Mercurial is much like Git in almost every way in that it is distributed, and many developers also find it a lot more friendlier than Git. So if you look at Git's commands and you think, oh, those are not exactly commands that I understand intuitively, I don't really care for those, well, Mercurial might be the tool that you want to pick up. Speaking of picking up, a lot of people report that working with Mercurial is very, very easy. Getting up to speed is pretty simple, and a lot of the approaches that Mercurial uses is pretty easy to understand. The final thing that is very compelling about Mercurial is that it is used with Codeplex and Google Code. So if you have projects up there and you're currently working with Subversion or TFS, you can roll right out of there and start using a distributed system like Mercurial. So these free tools resolve themselves into two different camps: distributed versus centralized, or maybe a better way to think about it is networked versus Hive-based. And the decision between which one works best for you and your team, of course, is yours. However, you should know that people are rapidly moving away from the centralized system, if only because of speed. Git is a very reliable system, as is Mercurial, and having the ability to work locally and push remotely only when needed is a big, big bonus. Now, this can be good for some shops. Speed in working with Agile and XP technologies is very, very important. However, if you're more process-oriented and you take things a little bit slower, then maybe you won't notice the speed difference with working with Subversion. Ultimately, the choice, of course, is yours, and whatever you're going to use. Not only that, but whatever you're going to enjoy using. So make sure that you spend some time with each tool. And once you commit to it, make sure you learn it. Make sure it's understandable, it's intuitive, because you want to use it, you want your team to use it, you want to be an expert in it, and you want to enjoy working with it. Nothing is worse than fighting with source control, and nothing is more pointless. If you can't get source control to work, then your job is going to be a very frustrating environment. So far, we have covered the phases a developer goes through when they start using source control, and also what choices are out there. In the next section, I'll talk a little bit more about how to effectively work with source control on a day-to-day basis. In this next section, we'll discuss the practical things you need to consider when working with source control on a daily basis. And the first is, what are you going to put in the repository? You might be thinking everything. That's not really a good idea. Next, we'll talk about tagging and labeling, and that's going to help you when you look back over your source control as the years roll by. Then we'll talk about branching. This is something that people used to fear when working with big centralized systems, but now with these new distributed systems, it becomes not only easy, but almost necessary. We'll talk more about that. Merges are something that can cut your development day in half. Now, understanding how to wade through a pretty snarled merge can be a tremendous help, and we'll go into that. Finally, I'll discuss general source control manners, ways that you can get along with your team when things don't exactly go perfectly. When you first add files into a source control system, you want to be sure that they're not derivative, meaning that you only want to add files that will go into building the other things in your project. For instance, you want your code files, but you don't want what they build, the binaries, because they take up unnecessary space, and they can actually cause people who download your project some headaches. Now, it's much better in terms of data to pass in differential scripts instead of the entire database. That way people can apply the differences to their project. You don't just take an entire MDF file and overwrite the one they're working on. That will actually cause some serious pain. All project artifacts, images, documents, and so on should go in. Anything that's required for the site to run and to operate that is not actually built by the site. Finally, project dependencies like external libraries should be added as well, making sure that all the references in that project come from that directory. This way developers don't have to guess and go and find those dependencies online or in a network share somewhere, and that can cause headaches as well. In terms of what not to track, as we discussed previously, you don't want to have any built files in there. No binaries that your project creates when you hit F5. You can usually set rules to ignore this, and one good rule to add in for your source control is to ignore the entire bin directory if you're using Visual Studio. Once again, you want to be sure not to push database files, anything in your app data directory. Don't push any of that. Omitting any kind of application log files will make you many friends. Those log files can grow on your development machine. It can take up a lot of space, and they're quite irrelevant for anybody else but you. So you want to make sure you omit any kind of log files you're outputting in your project. Now, it might seem kind of a good idea to put media files in if you're streaming video, for instance, but it's actually a very, very bad idea. This is primarily because serialization into the repository can mess with the video files, and I speak from experience with that one. Pretty much you want to make sure that these are up on a network share somewhere. People have access to them and they can download them as they need to, but these are not artifacts that should go into your repository. Finally, you want to be sure to omit any settings files. These are user specific and they are locking files and so on, so you want to make sure you don't add those to your repository. Next up, let's talk about tagging and labeling. Tagging certain commits can be really helpful when trying to track down a troublesome commit over time. If you're looking at a repository that has been in existence for years and years, you can step through all the commits simply by looking at tags, and it can really help you in terms of navigating. So what is a tag? Why should you use it? Well, a tag marks a commit as significant. This is something that might be something like beta 1, beta 2, RC1, something meaningful, something relevant to your project. Perhaps something like my birthday would not be a good tag. Finally, the name should be recognizable to the team and the management, maybe be company specific, such as iteration 12 or possibly initial release will be very, very helpful for someone navigating all the commits of a project. Branching is an effective strategy for allowing work to go on in tandem, outside the major effort of the project itself. This can come in the form of a spike, a new product version, or perhaps just some exploration by members of the team. Branching is thought of differently between distributed systems like Git and Mercurial and centralized systems like Subversion. Generally speaking, Git and Mercurial embrace branching because of their speed, and also because merging branches is a lot easier with these systems due to algorithms they use and the way the repositories are actually physically structured. And given this, Git and Mercurial advocate a lot more branching than something like Subversion. In fact, they go as deep as saying you should branch per feature. Sometimes you could even branch per team per feature, or just a plain old bug fix. Create a branch, start working in it, integrate it right back into the main line whenever it's ready. This keeps the main branch, the origin if you will, clean and bug-free for the most part. People aren't arbitrarily just checking in, whatever. With Subversion and other centralized systems, a general rule is to branch when two developers on the same team need to follow different rules. Branching is a bit more difficult with Subversion, but not terribly so. Exploring a new feature, possibly, or revving a new version, each of these is a good reason to branch. If branching separates efforts, then merging can be thought of as bringing them back together. Generally, when you merge, you can merge two branches together, which is hopefully rather seamless if the developer who created the branch is disciplined. Sometimes you actually need to merge commits. Someone who took out a file, worked on it, you worked on the same file, you try to commit together, and boom, you've got a problem. It happens from time to time, and you're each going to need to reconcile or figure out which changes need to go in. It can be less than fun depending on your system, and some are easier than others. As we mentioned, Git and Mercurial use different algorithms for merging files, but when you do have to merge the files together, most systems come with a tool called a diff tool, which is just a text tool that allows you to compare two files, see the differences, and synthesize the two. Now, overall, this isn't too difficult to wade through. Everyone has to go through some difficult merges from time to time. But if the tooling is there to support you, well, then it becomes rather simple. I can say this from experience that even if you buy the top shelf systems out there, the ones that charge a lot of money, merging is a fundamental exercise. And sometimes it is just as difficult with a big system as it is with a small system like Mercurial. What it requires is opening up a diff tool, and you just have to synthesize the changes. Make sure you call or email the other person that you're working the diff with, and then you check it back in. There's a lot of different ways that these merges can work. Git and Mercurial actually track the change made when doing a merge as its own commit, which is a little bit different than, say, Subversion, which tracks those things a little bit differently. When you do need a merge, it's important to be professional and civil, have good manners if you will. It can be quite frustrating at times. Temptation to send cranky emails can be overwhelming, but it's important that we have good etiquette. And speaking of good manners, here's a couple of things to keep in mind when you're working on a big team using source control. Number one, you want to make sure you keep your source clean and bug-free whenever you commit. You never want to check bugs in. That is considered number one taboo. Number two, you want to check out only the files you need if you use a locking system like Team Foundation. Now, Subversion lets you work on all the files on your local hard drive. Other systems like Team Foundation and SourceGear and Perforce make you check those files out, locks them in the source repository so others cannot work on them. In that way, you only want to make sure you check out the files that you need. Next up, comment your stuff concisely and professionally. You want to make sure you add details about what you changed, why, even adding issue numbers if you're working on an issue tracking change. Make sure you add very clear comments. Same thing goes with labels. You want to make sure that whatever label you put in is relevant and means something to the team. Finally, you want to handle merges gracefully. You want to make sure you work professionally because someday it will be all your fault. How you handle it when it's not your fault will all come back to you in the end. So in summarizing this episode, remember, always use source control. Select one that works for you. Learn it as well as you possibly can. It'll be your best friend and save your butt more than once. Next, always use source control. Make sure you communicate clearly with your check-ins and labels and use the system to your advantage in terms of communicating what it is you're doing. Keep bugs out of the repository. You never want to check in a bug that is going to label you as a rookie faster than anything. And finally, always use source control.